Today we are going to talk here about the role of zinc in blast furnace process. The very important thing that we have to learn about zinc is that reduction of zinc oxide is at much higher temperature than the boiling point of zinc. Hence what happens that as soon as zinc oxide gets reduced, it vaporizes and takes shelter in the stack of blast furnaces where temperature remains low, and second is any gap between refractory where temperature remains less. These are the most favored place for vaporized zinc to take shelter. And once this zinc becomes condensed on the refractory of low temperature stack area, it forms a creation, or we can say deposit. And once it gets loaded by increasing its size, because the position of this zinc vapor, uh, try to find out a higher surface area also, and the creation which has got a more surface area are the better place to provoke these zinc vapors to be deposited. Hence, the places which has formed with the accretion, already accretion, they are the more favored shelter for this zinc vapor. This is a slide which shows that in the process product of blast furnace, slurs are the most contributory product which discharge this zinc, and this zinc contribution in the sludge, blast furnace sludge, is much higher. It is supposed to be the highest, we can say. Now coming to the input raw material, as we can see, sinter is a dominating burden through which a lot of zinc is going to participate, going to enter in blast furnace. Now the question arises that how zinc act, which is already discussed a lot in the first slide, almost it is the similar. The only thing is which I want to mention, that upper part of the furnaces, which is around 7 to 10 meter, are most favored places for this uh, zinc vapors to mm, uh, take shelter. And as I have mentioned already in earlier slide about the cracks, are the very favored places to hide, take a shelter by this zinc vapors. This is one illustration in a slide which shows that how the concentration of zinc across a vertical height of blast furnace remains. As you can see that there's almost these 7 meter levels having got a highest concentration of zinc. Apart from that, these are a much lower area where we have a lot of more concentration of zinc is visible. Now question arises then, when the accretion fall, or when this accretion peel off from stack region to inside the furnace in the downward direction as load is tremendous and this burden has bound to move downward direction. So what happens that as this is a huge mass and it is not getting prepared as a normal burden of blast furnace, so it absorbs a lot of heat in the uh, lower region of the blast furnace, and this oxide basically a, it absorbs a lot of carbon to get reduced. And again, as this reduction is much higher temperature and its boiling temperature is much lower, zinc again vaporizes. So it's a sort of a cycle of melting and evaporation keep on going, and in the process there is a transfer of a lot of heat which is available in the lower region of the blast furnace is being carried away on the top of stack or on the upper region of the stack. So in this way, we can see that a lot of imbalance of thermal cycle occur. And this also or try to create a process upset as per the thermal stability of blast furnace is concerned. This causes a cold hot metal from the tap hole, asymmetric metal temperatures, tap hole to tap hole, and a many uh, irregularities in the casting, in the wind acceptance of the furnace, and several other reasons. Now, as the similar thing that we have already discussed, that uh, presence of these phenomena gives us a lot of negative effect, and as this process is a heat consuming, it create a thermal sink, a heat gap, thermal stability problem in the furnaces. And one more thing is that whatever the heat is being carried on the top of the stack is not also utilized, and hence there is a thermal imbalance, thermal instability occur in the furnaces. Hence, in order to have a better stability, consistent furnace operation, a stability in the production productivity, if we have to capitalize, we must have to focus on the phenomena of zinc accumulation and its optimization in the blast furnace. Thank you.